Welcome to this presentation on restroom control systems by Canvan Door Controls. Restroom control systems are often referred to as privacy systems, but I've also heard them described as communicating restroom systems as well. We have a lot of ground to cover today, so let's get started. In this presentation, we will be defining and describing the attributes of a restroom control system. We'll look at some of the applications for these types of systems. We'll talk about how large the market is for restroom control systems. There are a lot of equipment options that are available, so we really want to walk through those options for system designers and installers. Often, these restroom control systems need to be interconnected with fire, security, or communication systems, so we want to refer to that. And lastly, we want to help you find project specifications and CAD drawings should you have an application. So let's start with a description and definition for what a privacy system is. Privacy is simply the ability of an individual or group to seclude themselves or their information about themselves. Privacy overlaps with security, which includes the protection of people or information. And it includes a range of activities, such as the ability to work undisturbed, the ability to secure a room when needed, the ability to disrobe in private, or the ability to use restroom facilities, among other things. With that description, it's not at all surprising that we find privacy systems in a range of applications. We see them in healthcare applications as private rooms for examining or consulting with patients. We see them in nursing rooms where nursing mothers are able to breastfeed in private. We see them in secure police rooms for interrogation. And of course, we see them in single occupant restrooms. Note here that this does not include multi-occupant restrooms. Those applications typically have an open door into the room with locking stalls and typically don't have restroom control systems installed. But these systems are very related to other door control systems that are being installed, such as occupancy systems that are used in retail change rooms and in air trap and man trap applications where a lot of the same logic is being applied. Although there are a wide range of applications for privacy systems, they typically use the same basic components in a common system architecture. We start with a metal or wood door with a lock set. Typically, the system will use a storeroom lock that requires a key to open the lock set from outside, but allows free egress by room occupants to exit at any time. Next, we need an electrified lock. In most cases, an electrified strike is used, but we'll talk about other types of locks in just a minute. Of course, we'll need a push-to-lock device to activate the electrified lock. Doors that have an automatic door operator installed on them will also require a second push-to-open or unlock activation device. This switch is used to de-energize the lock and reset the system. If an automatic door is not present, occupants can simply exit using the lock set, and a door position switch will signal the controller to unlock the door. A device that indicates that a room is occupied outside the room or locked inside the room are important to communicate room status. Please note that some applications may also require remote enunciation. This could be a signal being sent to a remote customer service desk or a security office. Lastly, we need a logic controller to tie the system together. The controller needs to know that the door is closed before the electrified lock is allowed to energize, and to then illuminate local or remote indicators. Now that we know the basic components of a typical privacy system, let's review the many options for each device shown on this slide. Let's start by looking at the range of electrified locks that can be used in privacy systems. As we've discussed, electric strikes are by far the most common electrified lock that's being used. And these are typically grade 2 ANSI strikes designed for cylindrical and mortise lock sets. Note here that designers have the option to select an electric strike with a built-in latch monitor switch. This can be used to monitor the door position, which would avoid the need for a magnetic door contact. Although not used as often, I have seen magnetic locks being employed for this application. If this option is selected, however, please be careful because an override switch or power disconnect switch may actually be required by your local authority. Lastly, a mortise or cylindrical electrified lock set can be used. This lock replaces the standard mechanical lock set, and although these may be easier to install than cutting an electric strike into the door frame, you will need a power transfer cable to run wires from the frame to the lock that's mounted in the door. One of the most important choices that system designers have to make is in the selection of the activation devices that are used in the system. Push buttons are available in a range of configurations, including mushroom buttons, like the model that's shown here, but also includes other types of push exit buttons. No-touch switches have become extremely popular as a response to COVID-19 and make a lot of sense in restroom applications. If you select this option, there are some important design considerations, and we'll talk about those in a few minutes. It's not simply a matter of replacing a mechanical switch with just any touchless switch. Next, we have push-play switches that are commonly used when there is an automatic door operator. These push-to-lock switches match the push-to-open push-play switches used to activate the door operator and are available in a range of sizes from 2 by 4 inches all the way up to 36-inch tall models. Rather than using a switch to lock the door, it is possible to use a sensor to detect when a room is occupied. There are a wide variety of detectors available, but it is essential to match the sensor operation and the beam pattern of the sensor to the physical design of the room where it is being installed. This is to prevent false activations. And lastly, an electrified lock can be maintained in a normally locked state with a card reader or keypad used to gain entry to the room. I should point out that the biggest investment in new privacy system design is being funneled into new activation devices. You can expect a lot of new types of activation devices being introduced over the next few years. There are a few options for local occupied and locked status indicators. Narrow or single gang LED plates are by far the most common type of indicator or annunciator. Another option would be to mount a dome light above the door, but we're also seeing a new generation of integrated devices that combine LED status annunciation with the activation device. The model shown here also includes instructional signage for the system user. I want to end this section by talking about the logic relay. Although it's possible to program an access control panel for privacy applications, a dedicated door relay controller has the advantages of low equipment cost and factory default programming. That factory default programming enables the installer to select the desired system operation from a list of menu options and complete the installation in just a few moments. Now that we've reviewed the attributes and scope of privacy systems generally, let's dive into the specific application of privacy systems used in restroom applications, and particularly restrooms that have an automatic operator on the door. Restroom control systems are part of the emerging requirement for universal restroom design. Part of our social commitment is to remove barriers for persons with disabilities to both access buildings and for accessibility in the facilities within our buildings. That commitment is being built into new universal restroom designs and is now being written into new editions of state, province, and federal building codes. Universal washrooms are subject to several requirements addressing such diverse issues as the turning space, door widths, grab bars, counter heights, signage, and in some jurisdictions, barrier-free access provided by the installation of an automatic door operator. Today we are seeing how building codes are being rapidly updated to mandate the requirements for barrier-free restroom access. The Ontario, Canada Building Code Regulation 368/13, which became effective in 2015, was the first code in North America to dramatically expand the installation of low-energy automatic door operators on restroom doors in most non-residential buildings, including virtually all commercial and institutional buildings. Many of the requirements that are in the Ontario Building Code are now being adopted by other provincial, state, and federal codes. As such, the Ontario Code should be viewed as the model for the emerging code requirements that we will have moving forward. There are two ANSI standards that are commonly cited in regards to the installation of automatic doors in restrooms. ANSI A117.1 is the standard for providing accessibility for physically disabled people, and ANSI A156.19 is the standard for low energy power operated doors. The installation of a barrier-free control system will require a few components that are needed in addition to the privacy system devices that we've already covered. Of course, we will need a low energy door operator and two ADA compliant push-to-open push plate switches. A really interesting change we've seen in the industry is how low voltage system distributors are now stocking low energy operators, and how more and more installers are learning to install them without relying on the support of an automatic door company. In addition to the operator and switches, we've spoken of the need to have a magnetic contact to monitor the door position when using an electrified lock with a door operator. In this illustration, we've brought all of the elements together into a complete barrier-free restroom control system. This block diagram is of a normally unlocked restroom door. The sequence of operation for the system starts by pressing the push-to-open push plate switch. That then tells the automatic door operator to open the door, and the door will close automatically after the occupant enters the room. When the door closes, the door contact circuit will close, telling the controller that it is now able to lock the door. The building occupant presses the push to lock switch, which then causes two actions. First is to energize the electric strike, locking the door, and the second is to illuminate occupied and locked status indicators. When the occupant is ready to leave the room, they press the push to open switch that's inside the restroom, and three actions will happen as a result of that. Firstly, the electric strike will de-energize and unlock This is very important because we don't want to have a situation where the automatic door operator is trying to open the door while the strike is locked. Therefore, there is a delay, a slight delay, on the energizing the automatic door operator. And of course, we will turn off the illumination of the locked or occupied status. It's important to note that the restroom occupant does not have to use the push to open switch inside the restroom. If they exit only using the handle of the lock set, the door contact will open when the door opens, and the controller will automatically unlock the strike and reset the system for the next user. Installing a barrier-free restroom control system in a normally locked restroom only requires the addition of a key switch, keypad, or prox reader or similar security device. The door control relay has the factory default programming needed to operate this system. Please note that a credential security device can be wired to activate the system alone or to be used with a push plate switch as a secondary activation device. The two illustrations we've looked at show the basic components needed for barrier-free restroom systems. I'd like to spend the next few minutes talking about enhancements to the basic components that better serve system users and have the potential to provide installation savings. The first enhancement we'll be discussing is in regards to activation devices, and particularly combination devices that combine the functionality of activation switches with built-in LED illumination of the occupied or locked status. This makes the system much easier for building occupants to use, but also dramatically reduces the installation cost by reducing the number of devices that are being installed inside the restroom. Should point out that the combination devices are not limited only to push plate switches. We also have LED combination push to lock mushroom buttons that are also available. Another system enhancement we need to consider is when we are required by code to install two high-low push plate switches to activate the automatic door operator. 36-inch tall switches meet the building code requirements, but are less costly to install and maintain. These switches are often referred to as low-touch switches because they can be easily operated by an elbow, knee, or foot instead of using a hand. As a further enhancement, new switch models are integrating a no-touch activation sensor and red-green status illumination into the switch. We know that no-touch switches are very important in a post-COVID-19 world. Barrier-free restroom systems that utilize touchless switches reduce the spread of germs and improve user convenience. There are equipment packages that include models with built-in LED illumination and instructional switch signage. If a no-touch option is selected, using a short-range wave-to-open touchless switch inside the restroom is essential to prevent false activations. False activation would result in a door opening before a restroom occupant is ready. Short-range models are designed to be immune to reflective surfaces and to be used in confined spaces that are typically found in restroom applications. We are going to finish our discussion on design considerations by looking at unique barrier-free restroom requirements that a system designer or installer may encounter. An application that pops up fairly regularly is restrooms with two doors. Typically, a restroom in a commercial building that has a door entering from a hallway and a second door entering from an office space. In this scenario, duplicate push to open and push to lock switches are used to control each door, and the doors are interlocked so that the operation of the second door always follows the logic required by the restroom occupant. Another system requirement that you will encounter, at least in the province of Ontario, Canada, is the requirement to also install a press for assistance emergency call system in universal restrooms. You can purchase emergency call system packages that include all the devices you need, but it is essential that the emergency call system is interconnected with the barrier-free system so that the restroom door will unlock when the emergency call system button is pressed. This is needed to allow responders access to the room so that they can provide assistance. Next, some fast food or gas station restrooms are installed as normally locked restrooms due to concerns of vandalism or inappropriate use. In those applications, a remote activation device is placed behind the counter and staff press a button to open the door for patrons. Although the remote switch can be wired, a wireless activation solution is often employed. Lastly, multiple restrooms in a facility that are monitored by operations or security staff may require remote enunciation. These are typically custom built for each application. I hope you've enjoyed this presentation on restroom control systems. I'd like to end the presentation by assuring you that a full range of design, quotation, and customer support is available to assist you with your next project. This support includes a wide range of equipment packages in stock and available for immediate delivery. 3-part project specs and CAD drawings are available for a range of typical system configurations. There is help available with unique or special system requirements. Project quotations are available, and you always have access to installation technical support. For more information regarding restroom control systems or the diverse activation, control, and locking products that are used to make those systems, please contact Camden online at camdencontrols.com, by phone at 877-226-3369, or email Camden at csr@camdencontrols.com.